Okay, thanks, Professor. Good evening, everyone. I'm Wentao, and it's my great honor to attend the 30th International Symposium held by ISEG. And the presentation I want to deliver is about the use of expansive agents for enhancing the strength of cement stabilized clay slurry. My presentation contains four parts: the background, method, result, and discussion, and finally the conclusion. Let's move to the background. In China, a billion tons of dry clay slurry were produced every year, and the disposal of these materials has been a huge problem. The disposal of this material would consume a lot of land area, and in addition, the disposal of dry clay slurry would cause severe damage to the local environment and the ecosystem. One potential solution is that we can use the dry clay slurry as the feeding materials for land reclamation. Generally, there are two common methods. The first one is the vacuum preloading method. This method is relatively cheap, but it's associated with significant, and this method is time-consuming because the dry clay slurry would take several months or years to achieve a good consolidation degree. Another method is chemical stabilization. This method can be achieved by mixing the cementitious materials with the clay slurry. After the dry clay slurry can gain a relatively high strength in a short period. There are some challenges in the clay slurry stabilization with chemical binders. The one is in the high water content, which is around 1 to 3 times of the liquid limit of the soil, while another is the relatively small binder dosage because to be used as a feeding materials, the strength of the stabilized clay slurry is not very high. Some typical cases use the clay slurry for the stabilized clay slurry for land reclamation. The one is constructed at the Central Japan International Airport. In this project, 8.2 million cubic meters of dry clay slurry was stabilized. In the construction site, the dry clay slurry was mixed with the cement in the pneumatic pipeline and was then delivered to the reclamation site. And this method is the validation, and afterwards, no further construction is required. While in the construction of the port of Valencia, Spain, about 1 million cubic meters of dry clay was stabilized. In this site, a 4-meter thick crust was formed before the installation of the PVD pipes. So to promote the use of chemical stabilized clay slurry, there are two questions that we want to deal with. The first one is to reduce the use of cement to reduce the carbon emission as well as to reduce the construction costs. In this case, we can use expansive agents to enhance the strength behavior of the cement stabilized clay slurry. What is expansive agent? Expansive agent is cement additives that are used to decrease the concrete shrink. The main components of the expansive agent is calcium oxide, magnesium oxide, and the calcium sulfur aluminate. The reaction of expansive agent between expansive agent and the water would result the production of portlandite, brucite, and anthracite. These materials are bulky materials, and the reaction will consume a lot of water. So therefore, if we mix expansive agent with cement stabilized clay slurry, the expansive agent would absorb a larger amount of water, and to produce the voluminous materials to fill the voids in the cemented clay slurry. So in here, we use both ordinary Portland cement and the expansive agent, the slurry form dry clay slurry, to convert it from the liquid form to a solid mass by adding ordinary Portland cement and the expansive agent. These two materials are both purchased in Singapore, and the main components of these two materials are listed here. For the ordinary Portland cement, the main component is the calcium oxide, and there is a high content of thick oxide. While for the expansive agent, the main content is calcium oxide, and there is a relatively high content of the sulfate oxide. So what is the strength behavior? So in here, the picture on the left shows the unconfined compressive strength of the stable clay slurry with the curing edges. When the OPC content is relatively low, for example, if we use the 40 kilogram per cubic meter of OPC content, its strength was relatively slow even after 56 days of curing. If we change, and the strength of the stable clay slurry would also increase with the curing edges as well as with the binder content. When the OPC content was 80 kilogram per cubic meter, we added the expansive agent to this OPC, and we also tested its strength behavior. As can be seen in the right picture, the addition of expansive agent can significantly enhance the strength of the OPC stable clay slurry. At 7 days, the addition of 2 kilogram per cubic meter of expansive agent would enhance the 7-day strength to around 2 times of the sample without EA addition, while at 56 days, the addition of 1 kilogram per cubic meter of expansive agent would raise the strength of OPC stable clay slurry from around 200 kilopascal to around 450 kilopascal. Microstructural analysis was also tested. The XRD patterns above is the XRD treated clay slurry. As we can see, the major hydration products in this sample is the CSH, CAH, and intrinsic. While with the addition of expansive agents, the presence of gypsum was detected, and in addition, the XRD peaks of CAH was not so prominent in the samples with EA addition. Instead, the peaks of calcium aluminate sulfate hydrates was more prominent in the samples with EA addition. So we can draw a conclusion is that with the addition of expansive agent, the presence of gypsum and CASH was detected. Thermal gravity analysis was also conducted. The purple line shows the TGA curve of the unstable clay slurry, while with the as we can see from the red line, this is the TGA curve of the stable clay slurry with the addition of and expansive agent. As we can see from the DTG curve, the addition of expansive agent leads to the generation of higher volume, higher mass loss. This indicates the generation of more amounts of hydration products, including CSH, CAH, and F and intrinsic. In addition, more calcite was also detected in the samples with EA addition.
1 minute.
Okay, noted. SEM analysis was also conducted. As can be seen for the OPC stable clay slurry, there are lots of micropores here, while in the samples with EA addition, its microstructure is more denser. Similar observation can also be found in the SEM images with a magnitude of 2500. So here is the conclusion. With the addition of a reasonable amount of expansive agent, it can significantly enhance the strength of the OPC treated clay slurry, and at the same curing period, EA addition could promote the generation of more amounts of hydration products, leading to the denser cementation structures. So that's all my presentation. Thank you.